Okay, the vector is the one, it's a quantity has which has both magnitude and direction, right? Magnitude is used to define what is the amount, okay, and the direction gives you in which particular angle or which particular direction it has been applied. Okay, so that's what is a vector. And then we understood a concept that in basics of vectors we have studied each and every what you call as the operator. Each and every operator can be applied to a vector like addition, subtraction, multiplication, etc. But the mathematics has a very important operator which is differentiation, and the inverse of differentiation which is called as integration. We need to apply them. We need to investigate whether we can apply those particular uh, functions. Can you apply them to the vector, right? In that aspect we have a specific branch of mathematics called vector calculus. So out of that we are studying the first part as a derivative of a vector. So here we are trying to understand whether you can apply differentiation to a vector. Okay, so in that direction. So first let us define that there is a point P in the coordinate system, say denoted by x comma y comma z. So when we have that point P, right, we can connect from origin to P and call it as a vector R, right? That is called as a position vector, position of any particular point from origin. Okay, that's just a point P. Now let us assume that I have a curve, right? I have a curve written out of which P and Q are 2 points. All right, now if you want to consider the point Q, then I need to, right, move from P to Q in a specific direction. So that direction is indicated by a vector which is delta R. Okay, now from the basics of vector addition, right? If you have a vector R and to that you add another vector delta R, you reach the point Q, which is nothing but R plus delta R, right? So that means I understand that I can go from one point to other point through a curve using the vector addition. Okay, so OP is equal to, you can see there we have written OP vector is equal to R vector, that is denoted as x comma y comma z are the coordinates. Using the vector notation I can write it as x into I cap plus y into j cap plus z into k cap, where I, j, k are the unit vectors, right? That's the standard thing. Now let us consider a idea that what if these x, y, z are the functions of let's call this, say they are the functions. They are the functions of another variable, say t, right? In that case, all the coordinates x, y, z will change and when the t changes. So x is a function of time, I can write x of t. Y is a function of time, I can write y of t. Z is a function of time, I can write z of t. Okay, so if at all you have the vector r denoted as r of t, then I should be able to differentiate to get dr by dt. So differentiation of r vector by dt. So that is equal to, right, vector r dash of t, right? R dash of t is nothing but limit delta t tending to 0. It's the definition, same definition we have used for differentiation, right? When t changes to t plus delta t, right, we have r vector becoming r vector of t plus delta t. So you can see that RHS is written limit this delta t tending to 0 r vector into t plus delta t minus r vector, right, of t whole divided by delta t. So using the basic definition of differentiation, we understand that yes, if the vector r is a function of time, I will be able to differentiate that with respect to time. This is just because the coordinates using which I represent that vector, right, they are the functions of time. That's all. So very simple way we can define that. Now we can use that particular concept, right, to understand this. When this particular delta t tends to 0, what happens, right? My curve is there as it is, but this particular the delta r was there, right, which was a smaller vector pointing from p to q. Now when this delta t changes, becomes 0, it is going to touch the given curve at only one point, that is p. So any straight line touching a curve at a single point is called as a tangent. So now I know that when the delta t tends to 0, my curve, the vector which I had earlier, is going to become now a tangent vector, right? So dr by dt is the technique to obtain what is called as a tangent vector to a given curve at a given point t, point p, right? So the whole idea is pretty straightforward now, right? If a curve is given, you have to find the differentiation of a vector dr by dt to get the vector which is a tangent at the given point p. Okay, so earlier in the basics or previous to these chapters, we already have studied analytical geometry. In analytical geometry, what we had studied is that if you have a curve, differentiation of a curve at a point gives you the slope of the tangent. Okay, that concept we already know. But now it slightly modifies because we are dealing with a vector. What happens here is if you differentiate, right, the given position vector, you get the tangent at that particular point. It is not just tangent, it is a tangent vector. All right, that's the first point. Okay, now let us apply this concept to what is called as velocity and acceleration. So here we will assume that the motion of an object is defined by a position vector, that is r, x into I cap plus y into j cap plus z into k cap. Okay, now whatever point you consider on the curve gets connected to the origin, we call uh, that particular vector as the position vector. Now if you consider a different point on the same curve, then we understand that the line will move, the vector will move to a different position, so you get a different vector, different pointing vector. So the point is x, y, z will be definitely the functions of time, so that r is also a function of time. So r represents the movement of a point along the curve, which means if you have the equation of motion from physics, we are writing this, you differentiate that to get a velocity. So now the r vector what I have is a position vector of the point which is moving on over a line. You are tracing the curve, which means if you differentiate this r with respect to time, I should get the velocity. So using that concept, now you can see here the v vector, which is velocity vector, is dr by dt. R is the position vector. So we call this as velocity of that particle at a given time t. Okay, this is the first concept. It's applied as it is. Now the second concept which we have already studied is called as acceleration. Acceleration is nothing but derivative of velocity. Now velocity is a vector. I can definitely differentiate that. So dv vector by dt is going to be the acceleration. So we have the acceleration, but velocity is once again a differentiation. So d by dt of dr by dt, right? That is called as, right, the other equation of acceleration, which can be simplified as d square r by dt square. Okay, fine. Now we have few representations using which we can write all these concepts. That is, if you have a r, I can write r as r of t as well. So the first two lines are the definition of the position vectors, right? You can write x into I cap or x of t into I cap. Both are fine. Similarly, y and z can be written as y of t and z of t as well. So now this velocity also a function of time only. So v cap, you can write as v vector or v vector of t, both are fine, which is dr by dt. You are applying dr by dt in the sense x will be differentiated dx by dt, dy by dt, dz by dt, which is r dash. Same thing you can apply dr of t by dt, right? Dx of t by dt I cap plus dy of t by dt into j cap, and so on. Like that you can write. So differentiation results in r dash of t. Same thing, acceleration can be written as a vector or a vector of t, which is once again dv by dt or dv of t by dt. Same thing you can apply and you can write the functions in this way. So different textbooks will give the notation in different ways. Anything you follow should be fine. Okay, then we go for some of the properties, right? The first two properties are straightforward. We don't have to make any proof for that. Okay, so that is if you have, let's say, d by dt of c1 into r1 of t plus c2 into r2 of t, where r1 and r2 are the two different vectors. Whenever you have that, that is equal to c1 dr1 of t by dt plus c2 into dr2 of t by dt, right? That is because the differentiation is a linear operator. You can move it right inside the bracket and you can split the term. All right, that's what we had already learned in basics, so you don't have to prove it. The same thing is applicable for the difference as well. So you can see in the second point, the d by dt of c3 into r3 of t minus c4 into r4 of t, right? That is nothing but the d by dt goes inside the bracket and gets applied to two different vectors present inside your brackets. So C3 into dr3 by dt minus C4 into dr4 of t by dt. So that's how we are trying to represent. Okay, then we go to the one of the very important proof, that is what happens when you apply the differentiation of a vector to a scalar product, right? Simple differentiation is fine, but when there is a product, I know that normal method of solving the differentiation or applying a derivative to a product, there is a product rule. Okay, but this is not a normal product, this is a dot product, right? Dot product is quite different than our normal products. That's why, will there be any difference, right? To investigate that, we need to consider this particular proof. So the proof of this is d by dt of f dot g. You see that there is a dot product. F is a vector, g is a vector. When f both are vectors, it's equal to first vector f vector dot differentiation of a second vector plus differentiation of first vector into the second vector as it is. This is what is the meaning of this statement, right? So you can see we'll give the proof of this as follows. So we start with the definition of f and g vectors. F is f1, f2 and f3 are the coordinates multiplied by I, j, k respectively. Same thing happens with the g, g1 into I cap, g2 into j cap, g3 into k cap, right? All these are functions of time. That's why they are denoted in terms of t. Now you see, if I write d by dt of f dot g, both are the vectors, this has to be, right? What is f dot g? It's actually term by term multiplication, f1 g1 plus f2 g2 plus f3 g3. So it's d by dt of that. So we'll write a short form notation that d by dt, this is nothing but the d by dt of summation f1 g1. Summation f1 represents f1 g1 plus its next term, that is f2 g2 plus f3 g3. So as many numbers you can write, you can fill this, but in this case only three terms, because the vectors are represented in three dimensions. All right, so I also know one more point, that my summation and d by dt I can actually write exchange their position, using which I can write the summation outside here and I can take the d by dt inside. Okay, so that means fi gi is as it is, right? Summation, so it's like f1 differentiation of dg1 by dt plus df1 into this. Now the summation I'll bring inside. Summation goes into the product as different value. So summation f1 into I, because f1 has a component I and dg1 also has a component I. So summation dg1 by dt into I. Same thing is applicable for the second term, and you write this. Now summation of fi is what? Fi in f1 into I, f2 into j plus f into k is capital F. Okay, same thing. dg1 by dt, its summation indicates all the terms, which gives you the complete vector g. Right, same thing applicable to the next term, and we fill it like this. So you can see that we have proved this particular, right, identity. Okay, this rule is important, and we are going to apply whenever we want to find the differentiation of a dot product. Okay, after that, now we have another type of product possible whenever you consider the vectors. So that is called as the vector product or a cross product. So now our intention is to investigate what happens when we try to differentiate a cross product. Okay, so the statement is d by dt of two vectors f cross g. Now you see it's not dot product, it is a cross product. So f cross g is nothing but f vector cross dg by dt plus df by dt cross g vector. So this particular cross product becomes two different cross products. To prove that, we'll start with f is equal to the same definition, f1 into I plus f2 into j plus f3 into k cap. So g is equal to g1 into I cap plus g2 into j cap plus g3 into k cap. Right. Now, how do you define the cross product? It is a determinant. So we'll write a determinant I, j, k. First, if you write f cross g, the terms with the coordinates of f will come first. So it is f1, f2, f3, followed by the second vector, that is g, right? g1, g2, g3. Remember, if you had written g cross f, g1, g2, g3 will come first, f1, f2, f3 will come in the third line of the determinant. Now, once we write this, next what we do, we directly write its simplification. So simplification of a 3 cross 3 determinant is shown here. So I into, right, determinant of f2, f3, g2, g3. It's f2, g3 minus, right, g2, f3. Similarly, next term is minus of this j into, right, I need to write the determinant of f1, g1, f3, g3. So this part. So that will be written as minus j into f1, g3 minus g1, f3. So the last term is k, right, that is plus k into, I should write this determinant. Okay, so we write then in this fashion. But since once again there are three different terms, we can give a short form to that by writing summation I cap into first term itself, f2, g3, g2, f3. The next term will be f will become, right, f3, and g will become g3 will be, it will be replaced in the similar fashion. I becomes j, j becomes k, and so on. We can write in the same way. Okay, so that means let's write the left hand side once again. That is d by dt of f cross g is nothing but the d by dt of this particular term which we have written above. Because previously we were considering only f cross g. F cross g is that summation. Now we apply the d by dt to this. So you see here, when we are applying the d by dt to this particular term, we'll see what happens, right? This is going to indicate that in a very simple fashion, right? The I vector is as it is, d by dt can be brought inside the summation, right? So we get d by dt of this. So you can see here summation I, d by dt of a product has to be found. So d by dt of this minus d by dt of the second term. Okay, in the next step, right, we will expand them. That is d by dt of f2 g3 is nothing but f2 into dg3 by dt plus df2 by dt into g3. Normal, right? Normal product rule. Same thing is applicable for the next term, that is d by dt of f3 g2. So f3 into dg2 by dt, df3 by dt into g2. Out of this, now we'll try to reshuffle. So you can see that by looking at the colors, you can trace it out. First, yellow colors, it's as it is. Then I write the term containing dg2 by gt. Okay, that was actually present in the second term. Then I write summation I into f2 terms I club. Okay, so when we club the f2 terms, we get this whole thing. Okay, now we can this in another mathematical representation, you can write it using the determinant once again. So this is ijk f2, f functions are as it is, so f1, f2, f3 you can write as it is. Since the differentiation has been applied to g terms, you can write the differentiated terms over there. So you can see the first determinant is going to be like this: ijk f1, f2, f3 dg1 by dt, dg2 by dt, and dg3 by dt. Okay, its equivalent on the other side, I have the second determinant coming up as a result of this second summation. I can see that f functions have been, sorry, the f functions, whatever you see, they have been differentiated. So whenever I write the f terms, I should differentiate, you can see here. And whenever we are writing the g functions, they are as it is. So this means it can be represented as f vector into dg by dt, that's the first term, and plus df by dt into the g vector. That's the proof. Okay, after that we saw some of the important concepts which we already have studied in the basics, but we want to apply those concepts in when we solve the problems in this chapter. So that's why I gave as note. So the first note point is, you have a vector A and you have another vector D, but now our intention is to find out, right, what is the component of that vector A, what is the component of that vector A along another vector. Okay, so that is the basic idea and the concept. So A dot n cap is the answer. So n cap is given by vector D divided by magnitude of that vector. This can be applied to finding out of any given unit vector. You know a vector and you want to find its unit vector, means divide by the magnitude. Okay, so find a unit vector and take a dot product with the first vector. That's how we try to find out the required answer. Okay, that's the first thing. Then the second thing is component of a vector in a perpendicular direction. So that is nothing but it's a magnitude of vector A minus its component along D vector into a n cap. Okay, so that the equation is magnitude of A vector minus A vector dot n cap into n cap, its magnitude. Okay, so we saw that concept after this. Then later we looked at the concept of what is called as a unit vector normal to a given curve. Normally the curve is in space, that's why the name is given as the right space curve. Okay, normally that's how it is given. Now let capital A is a fixed point on the curve, right, and the arc length is denoted as S. Okay, so let's say that arc AP is given as S, and you see that the P is given by the X, Y, Z coordinates. So the position vector of that point P, by definition, by default, we can write it as X of t I cap plus Y of t j cap plus Z of t into k cap. Okay, after that, the unit tangent vector first we want to find. How do you find that? Differentiate. So that is dr by ds, nothing but dr by dt into ds by dt. But ds by dt is nothing but once again the dr by dt only, its magnitude. Okay, so first we find out the t cap as t vector divided by magnitude of t vector. So that I understood. Now in order to find the n cap, I use a property, that is t dot t is 1, because t is unit vector in a direction. A dot product of the same direction is going to get you 1, magnitude only. Okay, so differentiating that, I'm going to get, so you see here, this is first function into differentiation of second function plus second function into differentiation of first function. They are same, that's why I can write 2 times, oh my mistake. So you can simply write 2 times 2t vector into dt by ds is equal to 0. Okay, so which means dot product is 0, indicating that they are perpendicular. So it's very clear that t vector and dt by ds are perpendicular. So what I'm supposed to do now, so n cap is nothing but find dt by ds and divide it by its magnitude. That is the whole concept. So whenever I want to find a unit normal vector of a curve, I should just do dt by ds by magnitude of dt by ds. Okay, this whole thing is a theory concept, and later on we applied these concepts to some of the problems. The first problem which we solved was x equal to t square plus 1, y equal to 4t minus 3, z equal to 2t square minus 6t. So these are the x, y and z coordinates of the position vector, right, of the curve. So you can see that x is a function of time, y is a function of time, z is also a function of time. So using this we can definitely generate the r vector, and then we can proceed. That's the idea. And now also we can understand that in this question, part A of the question is find the unit tangent vector at a point, at any point on the curve. So tangent vector means differentiate. Fine. Second one is angle between the tangents. So find two tangents at t equal to 1 and t equal to 2 and try to find the angle between them. Okay, so we'll use the basic basic concepts only. This is not an advanced problem. So first you create your r vector. So from the basics what we have studied, r vector is going to be x into I cap, y into j cap plus z into k cap. Okay, now how do you find out the r of t? That is, substitute the values of x as t square plus 1, y as 4t minus 3 and z equal to 2t square minus 6t. So you can see that this is already given, right, and we don't have to make any other changes, simply substitute them. Now the first point is find out the tangent vector. So in order to find this tangent vector, what we try to do here is we differentiate dr by dt. So just look at the r of t and write the dr by dt, which basically we are simply differentiating every term. I, j and k are the unit vectors. They will be written as it is. You don't have to make any changes. But the other terms like t square plus 1 differentiation is 2t. So you can see in the answer 2t into I cap. It was originally t square plus 1. Then 4t minus 3 is there. Differentiation is right, simply 4. So this is 4 into j cap. Then you can see that 2t square minus 6t becomes 4t minus 6 because it's a differentiation of 2t square minus 6t. Okay, then moving ahead, what they have asked is not the tangent vector. What they have asked the unit tangent vector. You know a vector and you want to find its unit vector, means what you will perform, you will simply, right, you will simply divide by its magnitude. Right, so our intention is to divide this now, so we divide by the magnitude can be simply found, you can find it by under root square root of every term square. So 2t becomes 4t square, 4 becomes 16, 4t minus 6 becomes 4t minus 6 the whole square. So numerator is the vector which is written as it is, and you can see that the denominator is nothing but the term which I just mentioned. Now, in order to simplify this further, our intention is that we have to, right, make the substitution and simplify. Okay, so 4t square, 2t whole square becomes 4t square. Then we have 16 as it is. Then 4t minus 6 the whole square will be 16t square plus 36 minus 48 into this. So how did you obtain that? It is a minus b whole square, a square plus b square minus 2 into a into b. So once you get that, now let us say that the numerator, I can see that I think there is a term 2 common in all of them. So we'll write 2 into this is. So first term has t, second term has 2, third term has, right, 2t minus 3 because 2 has gone out. Ijk will remain as it is. Okay, then in the denominator you can see that the simplification will be 16 plus 4t square, so totally 20t square. Then we have the terms containing 48t and the last term is simply 52 times 52, that's 36 plus 16. Okay, once you have that, then I think I can take a 2 common from numerator as well as denominator. So in the numerator already 2 has been taken, but if you want to take out 2 from the denominator, since inside the root 2 becomes 4, so 4 will be taken out from the terms. So 4 goes out as 2, which means root of 5t square minus 12t plus 30. So this is the tangent vector. Okay, unit tangent vector. That's the first part of the question, and you can see that in the same question, the second part of the question states in this way, right? Find the vectors at t equal to 1 and t equal to 2 and find the angle between them. Okay, so to find the angle between the vectors, we need the vectors first. So how do you find the vectors? Name them as t1 cap because it is unit vector. Put t equal to 1 in the above equation, right? Just now we got an answer, right? So that is t cap, right? In this particular equation, right? In this equation of t cap, what do you do? Put every t is equal to 1. So you can see that this is 1 into I cap, 2 j cap plus 2 into 1 minus 3 into k cap whole divided by 5 minus 12 plus 13. So that simplified to I plus 2j minus k whole by root 6. Okay, then we have another term that is t equal to 2. So when you have t equal to 2, we'll write it as t2 cap. Once again, substitution of t is equal to 2 will give me an answer like t2 cap is equal to 2i plus 2j minus k whole divided by root 9. Right, now I want the angle, right? To find an angle, we have an equation that is the dot product. Dot product of any vector, two vector is magnitude of the two vectors product into cos theta. So since we know the dot product and since we know that they are unit vectors, cos theta can be easily found. Cos theta is t1 dot t2 whole divided by t1 t2, but t1 t2 is nothing but 1, so it's simply t1 dot t2 will give you the cos theta. So simply take a dot product, you multiply I into I, so there is a 2 into plus 2 is a 4, minus of minus 1 into minus 1 is plus 1. Okay, so that means our answer is 1 by 3 root 6 into 7, so that value is 0.9525. So theta you want, take cos inverse of that because on the left hand side I have cos theta equal to 0.95. So theta is cos inverse of that. Alright, so like that we solved the first question. Right, then let's move to the second question we solved. So this is find the unit vector, unit normal vector to the curve r vector is equal to 4 sin t into I cap plus 4 cos t into j cap plus 3t times k cap. So here the answer is right to find the n cap, right? N cap is from by the basic definition and the derivation which we did earlier. We know that I have to solve dt cap by ds whole divided by magnitude of dt cap by ds. So in order to find the dt by ds, I need the t, which is the tangent. So how do you find a tangent? Differentiate the given vector. So r vector I write down once again and then I differentiate. So how do you differentiate? That is dr by dt. Every term you differentiate. 4 constant as it is. Sin t will become what? Sin t will become cos t. Then you can see that there is a cos t term. Differentiation is minus sin t. So this is the answer. Then I have 3t. So differentiation of 3t is simply 3. We'll write that. Okay, then now that is a vector. I don't want the vector as it is. What I want is, right, I want its unit vector. So how to find that unit vector? You can find it, that is t cap by magnitude of t. So T cap is as it is. Magnitude is nothing but squaring every term under root. So you can see root of 4 cos square, 4 into cos t whole square. 4 becomes 16, cos becomes cos square. Next, minus 4 sin t becomes plus 16 sin square t. 3 becomes 9. So you can see that inside this square root in the denominator, we have written every term that is present in the numerator and it's a square. Okay, so that's what is this. I can see that the 16 is common in this. If you take a 16 out in the denominator, I am left with cos square theta plus sin square theta or t, that is 1. So that means it's simply, right, we are writing it as 4 cos t into I cap minus 4 sin t into j cap plus 9 into plus 9. The sum comes to be 5. Okay, so that's root 25, which is 5. So I'm writing it as 1 by 5 terms, 5 times this vector as it is. All right, in the next step, this is what is t. I need dt by ds. How do you find dt by ds? Dt by ds is dt by dt, dt cap by dt whole divided by dr by dt, its magnitude. Right, so this is 1 by 5, right, into minus 4 sine t I in minus 4 t into g. This is how you are getting this. You differentiate the above equation once. So 1 by 5 as it is. There is a 4 cos t. See, this is t cap, right? What I want is dt cap by dt. Differentiate. So 4 cos t differentiation becomes minus 4 into sine t. Then I have minus 4 sine t becomes minus 4 cos t after differentiation. And the 3 what you have here gets cancelled because 3 differentiation is 0 divided by this is the magnitude of that. So magnitude of dr by dt is nothing but the denominator of this term. So that is just 5. So you can see that I am writing 5 here. Okay, now after simplification I'll take the minus 4 outside and I'm left with this particular function as the answer, that is dt by ds. Now we will find the magnitude of dt by ds by doing this. How do you find the magnitude of dt by ds? It is magnitude of this whole function. So 4 by 4 minus 4 by 25 becomes plus 4 by 25 because you are finding only magnitude. You can leave the sign. Okay, then root of sine square theta plus cos square theta is root 1, which is 1. So your magnitude becomes 4 by 25. So we have to divide this particular term by the 4 by 25 to get our final answer. So how do you do that? Therefore, n cap is equal to dt by ds divided by magnitude of dt by ds. So dt by ds is written here minus 4 by 25 sin t into I cos t into j divided by 4 by 25. So the 4 by 25 will cancel from numerator and denominator. So you are left with minus of sin t I plus cos t into j, which is the required unit normal vector. Okay, straightforward. Let's proceed further. This was the next problem that we had solved. Okay, here you can see that the r vector is given as cos 2t into I cap, sin 2t into j cap, t into k cap. Okay, so first you find the t, which is nothing but the tangent vector. How do you do that? You can differentiate the given equation to get this. So there was a cos 2t, which is whose differentiation is minus 2 sine into 2t. Then we have sine 2t, differentiation is 2 cos 2t. We'll multiply that with j. And the third term is t into k cap. It becomes simply k cap. So magnitude of t is nothing but whatever t we got, take a square root and every term you write it as a square term and take a sum. So under root this is 4 sine square 2t, which is the square of 2 sine 2t. Then 2 cos 2t I have, which becomes 4 cos square 2t plus 1. So as a result of that, now I can see that this becomes 4 into cos square theta plus sin square theta, which is 1. So 4 into 1 plus 1 is 5. So under root 5. So root 5 is the magnitude of the given vector. Now I need to find the unit vector, right? That is vector t divided by magnitude of this. So this whole function is, right, 4 into this term. I should differentiate that with 1 by root 5. Okay, so we have this answer coming up, right? So from the given vector, I can simply write this as this. Okay, right. So after this, now I need dt by ds, which is nothing but dt by dt by dr by dt. So dt by dt, in the sense you have this t cap, differentiate that function. So 1 by root 5 is written as it is. Then we are writing minus 4 cos 2t, because there is a minus 2 sin 2t, sin differentiation is cos. 2 comes out, so 2 into 2, 4. Similarly, 2 cos 2t becomes minus 4 sin 2t into j cap. The k cap which is present over here gets cancelled after differentiation, right? So divide that by the magnitude of dr by dt, which is nothing but magnitude of this. I can see that this is already written here. Magnitude of t cap is equal to root 5. So I simply write that as root 5 over here. Right, that is dt by ds. So once you have the dt by ds, my next intention is to calculate the n cap, which is dt cap by ds whole divided by its magnitude. What is dt cap by ds? That is this function. Divide by the magnitude. Magnitude is nothing but this 4 by 5. Okay, so we write that. I can see that the 4 by 5 and 4 by 5 cancelling out each other, and after we cancel them, what is left out is the required answer, and in this case that answer is equal to minus cos 2t into I plus sin 2t into j. Okay, so overall that's the final answer. Okay, now let's proceed further, and we'll try to solve different sets of problems. Okay, so the next question is this. The moment of a particle defined by x is equal to e to the minus t, y is equal to 2 cos 3t, and z is equal to 2 sin 3t. Okay, calculate. Part A of the question is velocity. Part B of the question is acceleration at t equal to 0 is the question. So what I am supposed to do now, I need the vector first. So let's create the vector r, which is nothing but this is x into I cap plus y into j cap plus z into k cap. So what is that? X is nothing but e to the minus t into I cap. This is the position vector, plus y is nothing but this is 2 into cos 3t into j cap plus last term 2 into sin 3t into k cap. So we have the term present with us. Now let us try to write the velocity. First we'll write the velocity, then we'll write its acceleration. So what is v? V is nothing but dr by dt. So what is the differentiation of this term? It is minus e to the power minus t into I cap. So differentiation of cos becomes minus sine. So minus. So 2 into 3, that is 6 into sine 3t into j cap. Then sine differentiation is cos and it is positive. So 2 into 3 is 6 cos 3t into k cap. Alright, this is what is v. Now let's write acceleration. That is nothing but dv by dt. This is minus of minus is plus, that is e to the minus t into I cap. Then I am supposed to differentiate the sign, which is positive. So minus is there, it remains as it is. 6 into 3, 18 cos 3t into j cap. Then 6 into 3, it's negative, minus 18 cos differentiation is sine 3t into k cap. Alright, now the question is find the velocity and acceleration at time equal to 0. Okay, so what do you do? First we can try to find it's the magnitudes of velocity and acceleration. So what is magnitude of this is nothing but under root square root. This is minus will cancel out, it is simply e to the power minus 2t, because square of e to the minus t is e to the minus 2t. Minus is plus, 6 square is 36 sine square 3t plus 6 square is 36 cos square 3t. So what is this? This is nothing but under root e to the minus 2t into, sorry, not into, plus 36 into, take 36 common, sine square 3t plus cos square 3t. Right, so this term is 1, that's why the magnitude of v vector is nothing but under root e to the minus 2t plus 36. Okay, so this means at t equal to 0 you need to calculate what is magnitude of this v. So put t equal to how much? Put t equal to 0. So that is e to the power 0 plus 36. E to the 0 is 1. 1 plus 36 is 37. So root of 37 is the answer. Anyway, we can find the root 37 from calculator and write the answer. That is velocity. Similarly, we need acceleration. So I just have to find that from this acceleration equation. So just see that acceleration is e to the minus t minus 18 cos 3t minus 18 sin 3t. Okay, let's go to the magnitude of acceleration. So this is under root. There is already a e to the minus t, it's a square. So e to the minus 2t plus it is 18. So this is 18 square. 18 square is 324 into cos square 3t plus 324, one more 18 square into sine square of 3t. Okay, now this is equal to, once again we can write this as e to the minus 2t plus 324 into cos square 3t plus sine square 3t. So this is 1 once again. So which means I can write the magnitude of a as root of e to the minus 2t plus 324. So next part, at t equal to 0 calculate what is magnitude of a, that is root of e to the power 0 plus 324. E to the 0 is 1, so 324 plus 1 is 325 under square root. Okay, so this is the final answer. Let's go to another question now. The x is given by 1 minus t cube. Okay, then y is equal to 1 plus t square, and z is equal to 2t minus 5. Okay, so the question is find v vector and a vector at t is equal to 1 second. Okay, now first our intention is to calculate the r, which is equal to x into I cap y into j cap plus z into k cap. Okay, so let us substitute to get the answer now. So this is 1 minus t cube into I cap plus this is 1 plus t square into j cap plus 2t minus 5 into k cap. Okay, so this is r. Now let us calculate v. So v is nothing but this is dr by dt. So this is 1 minus t cube becomes minus 3t square into I cap. So plus this is 2t into j cap plus 2 into k cap. Okay, now no need to find the magnitude because the question says find v vector at 1, not the magnitude. So at t equal to 1, simply you can write, so v is equal to, put t is 1, so this is minus 3 into I cap plus 2 j cap plus 2 into k cap. This is the answer. Similarly, now I need to find the acceleration vector. So a vector is equal to, this is dv vector by dt. So there is minus 3t square, which becomes minus 3 into 2 minus 6t plus 2 into t becomes 1 now, so 2j plus 0. This is what is the a vector acceleration. So at t equal to 1, what happens to this vector? Vector a is equal to, now we can simply write this as, this is equal to minus 6, sorry I missed the I cap over there, minus 6 I cap plus 2 into j cap. This is the required answer. Okay, all right. Now let's go to a different question. Next question is this. Find the component of vector A, which is equal to minus 3i plus 2j plus 2k along vector B is equal to 2i plus j plus 2k. So you can see that we are trying to solve this by using the note which we had. So there was like a and d given, right? So component of one vector along other vector. So whatever is the other vector, you use that vector to find a unit vector. So that is n cap is equal to, right, that is vector b divided by magnitude of the vector b. So vector b is 2i plus j plus 2k divided by square root of 2 square 4 plus 1 square 1 plus 4. 4 plus 4 8 plus 1 9. So this is root 9, so 3, right? So our answer is 2i cap plus j cap plus 2k cap divided by 3. Okay, now our answer. Therefore, the requirement, I can write component of a vector along b vector is nothing but vector a dot n cap. N cap is just found, so we'll write that as it is. So a vector a is given. If you check the vector a, this is minus 3i plus 2j plus 2k given. This is given right in the question. That is a vector a. Along whatever you want, its unit vector should be written. So this is 2i cap plus j cap plus 2 into k cap by 3. So we know that it is a dot product. So I into I terms can be multiplied. So minus 3 into 2 is minus 6. Okay. Then next term is 2 into 1. Then 2 into 2, 4 divided by 3. So this is nothing but, you can see that they will cancel. So there is no